buddies, and welcome back to this masterclass for the beginner in Java. Today guys, we are going to learn about Java recursion, and this is just Java tricks and tips. Without much ado, let's get started. Welcome. So I'll start off by creating a new file here. This is IntelliJ IDEAL. So I'm just going to click this thing like an hamburger over there. So hamburger, just some donut. So then new project. I wanna call it Java recursion. So it's actually recursion. I copied this like I don't know. What do you want? This I don't want. Please forgive me. So Java recursion, then create. This window, yeah. Do it just right here. I don't wanna go anywhere. I just wanna stay here. Right? So I have already created the inner method, which is the main method. So from here, I'm just going to cut this down. There you go. So okay. So what is Java recursion, guys? So let me just define this before I punch some keys on my keyboard and things went wow. So Java recursion is the technique of making a function call itself. So if you can call yourself, that is something like that. So this technique provides a way to break a complicated problem down into a simple problem which are easier to solve. So recursion may be a bit difficult to understand, but the best way to figure out, you know what, we will just do it. That's the way we can figure out what am I even doing. So let's start by doing this example by adding two numbers together. And okay, before I say that, you see, actually adding two numbers together is easy to do, so that we all know that, but adding a range of numbers is more complicated. So for example, in this example I just want to do here, recursion is used to add a range of numbers together by breaking it down into a simpler task of adding two numbers. So let me just do it here. Okay, I just have to create an int here, then a result, and salt is equal to sum. I just want to pass in a number, let's say 9. And the JD is complaining that we don't have that method. Okay, I just click import static method. I don't know what you're saying. So I will have to print out and say I'll have to print the result. So this method is going to call a certain method. No, not a certain method. It's going to call itself. Okay? Once it calls itself, it's going to return a result. So let's do this method somewhere. So I just come down here and in this, in fact, this easy. I did. What happened? Okay, let me just do it. Okay, Control Z. I just wanted to do something, but I've decided not to. So let me just come down here and create this method. So it's pathway. So done this. Copy. So I'm going to pass here let's say a number. and then so before, what am I going to do with this method? This one need to calculate that range using the recursion. Now recursion is like a loop, something that's going to repeat until a certain criteria is reached. For example, this one, we want to add all the numbers from 1 to 9 by just adding the first. For example, every time that the recursion has happened, then we should subtract 1 from n. Then the number will just be decreasing by 1 by 1 by 1 until it returns 0. Yeah, that's what will happen right here. Just wait and see. Miracles. There we go. Okay, as I said, if, let me use if statement, because now I'm going to check whether n, that number, is greater than, it can be equal, greater than. Okay, if it's greater than 0, what should we do? There's something wrong here. Oh, sorry. Should be a curly braces. And then there is something wrong. Okay, let me just write it before that, and then I check if the number, this n, yeah, if n is greater than 0, continue doing it, right? Continue calling, continue happening. So return, I just wanted to return that number and then concatenate with, or plus with the sum again. Just did this now where this when our miracles happens. So it's n, that number negative minus 1, that is it. So every time that this calls, this number decreases by 1 until n is 0, then that is when it will return 0. Then we will exit out of the recursion. And I think if this is written wrong, it can even crash your computer, I'm very sure, because if it goes out of control or there is a bug somewhere, this will actually call into an infinite number. Okay, but this one, n, there's a point where n is going to be returned as 0, and that is when n is greater, n is 0, 0 is greater than 0. This will be something not true, and then boom, we jump out of the recursion. So I've done that, and then I should this finally, because this is an if statement, then you should have an else statement. So else statement, I think this error is for return. So once we're done with the else, just return 0. Yeah, else return 0. That's when we close the case. So if this number actually ends up to be, when n is 0, that's when 0 will be returned. Then we skip out of the loop. So let's see what will happen then. Let me just save it. So let's add all those numbers and see what we can get. So as it's running, let me just explain this. Let's just get the answer first, and we will be able to brag that hey, it's working. Okay, as you can see down here, starting the main and the tab, boom, we have 45. So let me just explain now. So when the sum, this method here, you see this method, or like I call it a function is called, it adds a parameter n this n to the sum of all numbers smaller than k. So this one over here. So, and it returns the result. So when n becomes 0, just like we said, what happened again? Yeah, so when n becomes 0, the function just returns 0, because this function is called all the time. So when n actually turns to be 0, so the function just returns 0. And then, so what actually happens in the first step, I mean, 9 is actually this over here, 9. Then, okay, what happened here? So 9 is here, 9 minus 1, we get 9 minus, I mean, is this minus here? 9 minus 1, we get 8. So it's actually 9 plus the sum of 8. And then the second time it's 9 again, 9 again plus actually 8 plus the sum of 7. Again, it goes like that until there is a point where it comes like, it ends like this, where it is 9 plus 8 plus 7 plus 6 plus 5 plus 4 plus blah blah until plus 0. Oh, it's a long number, just like that. Wow, this is awesome. We can't actually add this number just like that, but we just break them into the smallest two numbers that we can continue adding until we finish. So when the function actually does not call itself when n is 0, the program just stops there and they return the result as 0. So let's again do some halting conditions and explore with this a little bit. So as just loops can run into a problem of infinite looping, recursive functions cannot run into the problem of infinite recursion too. So infinite recursion is when the function never stops calling itself. So it keeps on calling itself 1,000 times, and it ends into an infinite number. So every recursive function should have maybe some halting conditions, and I think which is the conditions where the function can stop calling itself. So we should have this kind of mechanisms. Yeah. So in this example that we have done here, halting condition is when the parameter, this parameter 9, becomes 0. So that was the only halting condition that we ever had here. So I say if that actually got out of our control, then this could probably call this function into infinite number, and my machine and the memory will be full or something like that, and then boom, maybe it goes off just like that. So it's helpful, it's very helpful if we can see a variety of different examples to better understand the concept. So I just want to do one more example here, and I'll just add a range of a number between a start and the end, and then I put in some halting condition for this recursive function, and that will be when end is not greater than the start. Yeah, so that is what I want to do here. So I just use a recursive to add all of the numbers between 5 and 9. So I will be having my halting condition there where I'm just using the start and the end. So when the end is reached, that's when we cut off the recursive. So stop talking, just do it. So I just want to change a little thing here. Instead of now this, I just want a range from 5 to 10. And now it's complaining. So I'll just create an int here of, let's go start. What did I do? Okay, I just put a comma here and then an int end, just like that. So I have the start here, which will be 5, and the end will be, let me just have 10 there. So this method is going to be returning a result, and that is the result that we are going to print out every time, probably no, at the end. So we pass in 5, and then the end we check whether, yeah, so now this should be the end. So I will check whether the end is greater than the start. So the end always will be greater until it reaches 5. That's when it will be 5 is greater than 5. That condition will be something, yeah, something will go crazy there. So that's when we cut. Okay, so start here. So we will be checking whether the end is greater than the start, and we will be returning the end every time. So the end plus the sum of, so return the end, right? So the end will always be 10. So we will be returning that 10, and then the next number, and then the next number until we reaches 5, when 5 is not greater than 5. Or we can say it's greater or equal. Yeah, that's also okay. So it's either it's greater or equal. We don't want to go to the other side, but we will check that and to find out what is the difference. So I will just that. Then now this will be decrementing the end by 1 every single time it runs. So it's end minus 1. So every time we will be doing that. Yeah, that's cool. So we'll be decrementing the end by 1 every single time the recursion happens. Yes, so let's go to else statement, where we will be returning the end. So the end will always be 10, right? Okay, so let's run this. Yes, there we have 49. Let me change this, and so the result turned out to be 49. So we added the sum of 2 numbers each per time till we got that. Let's do, I just wanted to check this. This will be just, so it's still building, but something, oh, 45. But I think it's okay that we should return this over here. Okay, so you know, one thing that you need to notice about this is that the developer should be very, very careful with recursion, as it can be quite easier to slip into writing function which never terminates. So, or one that uses excess amount of memory or processor power, and however, when written correctly, the recursion can be a very efficient and mathematically elegant approach to programming. So that's an advice from the wolf. Okay, thank you so much guys for joining the class of today. There was too much stammering here and there, and that is okay with humans. Yes. So goodbye, have a good time.